Today we will also solve some example problems on AC circuits, steady state sinusoidal AC circuits. So let this be the first problem. So we have a circuit and there is a voltage source sin omega t AC source, and on the right side we have a voltage yt. Okay, it is like this, plus minus. It is given that yt is of the form a sin omega t plus phi, and magnitude of a is 0.25. Okay, so this plus minus doesn't matter because the mod of a is given. Anyway, now we have to find the value of omega. Okay, so how do we do this? We will use phasor representation. Okay, so suppose first, if the impedance of this capacitor is xc, okay, then this is also xc, this is also xc, okay, and these are basically complex numbers. Xc will be equal to 1 over j omega c. Omega is unknown. Now consider these two branches together in parallel. Okay, so what is the equivalent impedance of these two branches? One has the impedance of xc, another 2xc, so it will become 2xc into xc whole divided by 2xc plus xc. Okay, and then this resistance is in series, so plus R. Okay, now if I call this source voltage as V sorry, plus minus phasor, then V divided by this total impedance will be this current I, total current, total source current. Okay, so this is I. Now part of this current I goes through this branch with impedance xc, and the rest go through the branch with impedance 2xc. Okay, so how, if I call this I2, then how much is I2? I2 will be I multiplied by, right, so we are using current divider rule, so I multiplied by xc by 2xc, sorry, 3xc. Okay, so this is I by 3. Okay, so then yeah, so this will be I2. Now if this voltage is Y plus minus phasor, then how much is Y? Y will be then I2 into xc, so that will be I by 3 into xc. Okay, so from here we can write Y is equal to, so V divided by total impedance R plus, so this is 2/3 here, this is 2/3 of xc, 2 by 3 xc. Okay, so this is the current, we divide it by 3 to get I2 and then multiplied by xc. Okay, so this is Y bar, so this will be equal to V then divided by 3R plus 2xc. Okay, and then we can divide one more xc here. Okay, so this is equal to V by xc is 1 by j omega c, so we have 3j omega r c plus 2. Okay, now we know that the mod of y So that will be equal to mod of V divided by 9 omega square r square c square plus 4. However, mod of Y is equal to mod of A, that is 0.25. So this is 0.25, that means 1 by 4. Okay, so oh, I missed a square root here. Okay, so from this what do we get? So we get 9 omega square r square c square will be equal to 16 minus 12. So from this you can get the value of omega. Okay, so you can finish it. So any question here? Anyone? Okay, fine. So here is another question. Okay, we have a circuit and we have to, yeah, please go ahead if you have a question. Hello?
Sir?
Yes.
Sir, in the before question, like you wrote 12, means it is 16 v square minus 4, right? How you wrote like 12?
16 minus 4 is 12, no?
V square, 16 v square, right?
Yeah, but mod of V is 1, right? Because I know, okay, since mod of...
Oh, sorry,
Yeah.
sign omega negative.
Yeah.
Okay.
Okay.
Okay. Sir.
Yeah. Yeah, sorry if I didn't mention that. Achha, so here is the next question. So in this circuit, we have to find this current through the resistance. And consider this question as an MCQ question. Okay, so you have multiple options to choose from. So you need not solve it very rigorously because you can choose from the options. So now, to start with, omega is 1000. So what will be the value of XL, impedance of inductor? That is j omega L. So 20 milli into 1K, this will become J
20 J.
20 ohm. Yes, right. And how much will be XC? Sorry, 1 by j omega C.
20.
Yeah, it will also be minus J20 ohm. Yeah. Okay, now if so, so you see we have two branches, capacitor and resistance, they are in parallel. However, the magnitude of impedance of the capacitor is much larger than that of the magnitude of the resistance. So therefore, whatever current comes here through the inductor, sorry, that will mostly go through the resistance, and this current will be almost equal to 0 because that impedance is much larger. Okay, so we can use this approximation, and if we do that, then this current is also I approximately. And now how much is I? Sorry, how much is I then? It is 20 angle 0 degree volt divided by J20 ohm plus approximately 1 ohm. So which is approximately 20 volt by J20 ohm. So that will come out approximately 1 by J, that is minus J.
Minus J. Yes. First option.
Yeah, first option, right. Yeah, since we have the options, therefore we can do this approximately because you see all other options are quite far from option A. Okay. Yeah. So any question here? Fine. So let me take another question. Okay, so we have an infinite ladder circuit. Okay, so this same pattern repeats up to infinity, and how much is this ZEQ, equivalent impedance seen from the left side. Okay, so as I told you earlier that it is not necessary that in all questions everywhere complex numbers will have overlines. Okay, it is easy to put overlines to distinguish complex numbers from real numbers, but it is not necessary that we have to put it always.
Sir, can you please show the answer of the previous question? What was the value?
Here.
Oh, okay, sir.
Okay, so now how do we solve this? Okay, if I consider, say, this part of the circuit, okay, so from here to the extreme right, and if I then call this as node A and this as node B, how much is the impedance between A and B seen from the left side? It should again be ZEQ. Yeah, absolutely. Okay, so if so, now can we say that ZEQ in parallel with, so here we have plus J5 and minus J1, so that means plus J4. Okay, so ZEQ parallel J4, and then here we have J9 in series. Sorry, this should be equal to ZEQ again. Now we can solve this equation. Okay, so this will be ZEQ into J4 divided by ZEQ plus J4 plus J9, right side ZEQ. So we have one equation, one unknown. We can solve it to get the value of ZEQ. Okay, so you please do it together with me. So from this we get J4 plus J9 plus J square is minus 36, and right side will be Z squared plus J4. So this and this term cancels, and we have Z squared minus J9 Z plus 36 is 0. So now how much is Z? That will be minus of B, that means J9 plus minus root over 81, minus 81, and then minus 36 into 4, 144 divided by 2. So this will be J9 plus minus J 225 square root is 15 by 2. So we have two possible answers, but are both the answers possible in this circuit?
Only the plus one.
Only the plus one. Okay, so we should have
12J.
yeah, J equal to 12J, because overall this circuit is actually inductive. If you consider this J5 and J1 together in series, the inductive impedance is much larger than the capacitive one. So overall this is an inductive circuit. So we must have a positive imaginary number. Okay. Now,
Sir,
yes.
you repeat why the positive one?
Yeah, so the other possible answer was minus 3J. Okay, so but minus 3J represents a capacitive inductance overall. Okay, but this is not possible because you see what do we have? I mean, here we have a capacitor and an inductor in series, but capacitive impedance is larger. So overall this green branch, overall inductive. Now together with that we have another inductor. Okay, so inductor in series with inductor is another inductor. then again another inductive branch in parallel. So overall, if you
Yes.
yeah, so that's the point. Okay, now here is another question. So it is said that the voltage between AB Vt, that is sinusoidal, omega is given 100 radian per second, and this current IT is in phase with voltage Vt. Okay, so Vt and IT, they are in same phase. When is that possible? It is
When the
possible.
circuit is resistive on.
Yes, only if this overall impedance is resistive. Okay, so the overall impedance should be resistive. Now from this condition, we have to find what? The value, yeah, Z, the overall impedance. Okay, okay. So how do we do that? So first, Z, this is equal to 100 ohm in parallel with this capacitor. Okay, how much is this capacitor impedance? So that is 1 over, have you already done it?
100.
Yeah, if you do that, so that
Minus
is
J.
minus J 100 ohm. Okay, now together with this we have inductor. Okay, so plus, if it is XL, let me call it JXL, then plus JXL. Okay. Now, so this is equal to 100. I can take common. Then 1 parallel minus J. So 1 minus J divided by 1 minus J. Okay, plus JXL. This is in ohm, and so 100. So if we simplify, what do we get? Minus J. Let me multiply 1 plus J above and below. So denominator will be 2 plus JXL. Now this 2 and 100, so it simplifies to 50. So this is then minus J50 plus 50. This is in ohm, plus JXL, and overall this should be resistive. If so,
That
yeah, that
And
yeah,
axle should be
so that means these two terms must cancel
Will
each other. So we will have 50 ohm finally. That's the answer. Okay. Fine. Now another question. The circuit below is excited by sinusoidal voltage. R is in ohm. We have to find the value of R. How much is R? Such that the admittance of the overall circuit is a pure real number, pure conductance for all frequencies. Okay. So first let us find the admittance between these 2 points. Call it AB. Okay. How much is YAB? Okay. If I call this capacitor impedance as, let me call it just XC, and this as XL. Okay. Then how much is YAB?
Sir, what is the omega, sir?
Omega, it is said this overall should be pure real number at all frequencies. That means at all
Okay,
omega.
right. Sorry, sir. Yeah.
Okay.
Got it.
resonance.
We haven't studied resonance yet, so we will not use that term today. We will study it next week. Okay. Achha. So let me just do it in simple manner. So YAB for the upper branch, how much is the upper branch admittance? So that will be R if I write it say like this, minus jxc and this as jxl, okay, then it is r minus jxc here, this is for the upper branch, and then plus 1 by r plus jxl, this is for the lower branch. Okay, so now we can simplify this a bit, so it becomes r plus jxc by r square plus xc square plus this will become r minus jxl by r square plus xl square, and this should be real number, pure conductance. So that means the imaginary part which is this, this should be equal to 0. Okay, so that means actually these two terms are equal, right? Okay, so from this let us simplify. What will we get if we cross multiply? We get r square xc then minus xl plus, oh here a square, xl xc I will take common, and xl minus xc, this is equal to 0, right? Am I correct?
Yes, sir.
Yes,
Now,
sir.
let me write this as r square, and xc is 1 by how much is xc? It is 1 by omega c. xl is
Sir, xc minus xl can be taken out common, sir.
yes, I will do that, but before that let me just expand it as so this is omega L by omega C and 1 by omega this, let me make it minus, and 1 by omega C minus omega L. Now I will take this part out as common, because this term is not equal to 0. This term cannot be equal to 0. Okay, why cannot be 0? Because this condition has to be satisfied at all omega value. So if omega changes, this also changes. So even if it is 0 at one particular frequency, it cannot be 0 at this cannot be 0, this cannot be 0 at all frequencies. Okay, so this term is not equal to 0. So if that is not 0, I can divide by that term. So r square minus omega L by omega C, this term must be equal to 0, which means so omega goes away, which means r is equal to root over L by C, and the value of L and C are given. You can put the values and find out the value of r. Okay, so now here is another question. Okay, and in this question we have to find the current through this 1 ohm resistance. Here is the 1 ohm resistance. So we have to find basically the peak value of the current. Peak value of the current through this. Okay, how much is this current? Okay, so before we do that, let us first simplify this circuit. Let us first find out the omega L and omega 1 by XL and XC for all inductors and capacitors. Okay, so let us first say consider this branch. Okay, so here how much is xc? Okay, c is
Minus
2.
0.5.
You're saying
Okay.
this is minus 0.5. You mean minus j 0.5, right? Ohm. Acha. Then how much is XL for this 500 millihenry? J omega L. Okay, 500 milli into
Fine.
1, that is just 500.
500 both.
So, 500 ohm. J 500 ohm.
Sir, XC should be minus
XC will
J
be
500.
minus
Minus
500.
500.
It should be
Minus
500. Acha,
500.
okay, okay. So this is
Yes, sir.
500. Just put the values and check. Acha, if so, now how much is XC parallel XL?
Infinite.
Yeah, so that will be
Infinity.
something divided by 0. So that means equal to infinite. So infinite means no current will flow here. So this current will be 0. This current will be 0. Right? So that branch we can just forget. Now then, let us simplify this part. Okay.
This part also has infinite.
That also infinity.
Yeah, so here
This is
also
also-
we will see that XL, you just put the values and you'll see JX, sorry, how did I write it earlier? Okay,
Four.
XC parallel XL, that comes something divided by something by 0, that is infinite. So that means through this path also no current will flow. Okay. So if so, and this voltage source is 10 sine 1000 t, so how much will be I? I will
One.
be 10 sine,
ampere.
yes,
1 ampere.
1000 t divided by 4 plus 1 plus 5 ohm. Okay, so how much is the peak value then? Just 1. Okay, fine.
Sir, will the peak value be root 2 or 1?
Why root 2?
Hello,
This
sir.
is given in as a direct function, no? So there is no conversion from I mean functional form to phasor form or anything. This is direct value. Okay, so the root 2 doesn't come in picture. Okay. Acha.
Sir?
Yes.
So
Yes.
That's why I'm
Please.
10. I think 10 is given in R.
Your voice is breaking. Please repeat.
So the 10 sine 1000 t is there now. Is it not given in RMS value? Is the 10 is not RMS?
No, no. Why should it be? I mean, this is like you have a function
it
in
is
terms of t.
instantaneous.
Yeah, so Vt equal to like this. Okay. So this is not RMS value. If it is given in phasor, then normally by default the phasor magnitude is equal to the RMS value. But here just direct function is given. Okay.
Okay, okay.
Yeah. Okay, so this is another question. Okay, so here we have a source Vs. Vs is the voltage. Suppose this is plus minus. Then we have a resistance and then a coil. Coil means it has some resistance as well as some inductance. Okay, and the resistance voltage is VR, coil voltage is VC, suppose like this, plus minus. Okay, anyway, the plus minus do not matter here because the question is only asking about the magnitude of the these voltages. Okay. So let us read the question. A resistance and a coil are connected in series, and the supply voltage is 100 volt 50 hertz. Okay, the RMS value, I mean, what are the possible values, RMS values across the resistance VR and across the coil VC? What are the possible values of these resistances, these voltages, VR and VC? Okay, and since we are talking only about the RMS value, that means the magnitude of the phasor magnitude, the plus minus symbols are not required in this circuit, but we are assuming these plus minus symbols for ease of calculation. Okay. Achha, now, so we have 4 choices. One is VR equal to 65, VC equal to 35, another both VR, VC are 50 volts, and so on. Okay. Now, among 4 possible combinations of VR and VC, which one is possible and which ones are not possible? Okay. How can we do this? One way is to use a phasor diagram. Okay. So suppose this current is I. Okay. Then let me draw a phasor diagram. So suppose this current I, it's a complex number. So somewhere here maybe we may have I. Then how will the voltage VR will be? Okay, in complex plane, VR will be I multiplied by resistance R.
Same direction.
So that will be in the same direction. Okay, maybe here, maybe this is VR. And then how will the voltage VC be? Okay, if you want, we can break this VC into 2 more parts. Suppose this is V1 across this resistance, and this is V2. Then where is V1? V1 is again in the same direction as the current. So maybe this is V1. And in which direction is V2? That will be 90 degree leading. Maybe here is V2. Now if I add V1 plus V2, okay, so the resultant will be here. This is VC. So VC is leading I by some angle. Okay, let this angle be equal to theta. What can be the range of theta? What is the minimum possible value of theta and maximum possible value of theta?
0 to 90.
Yeah, so theta is between 0 and 90 degree. Okay, so it should not be exactly 0 because exactly 0 means this V2 is 0, that means inductance is 0. But since this coil has some inductance, V2 should not be 0, and again it should not be exactly 90 degree, because that is only possible if V1 is 0, that means the resistance of the coil is 0. But since some resistance is shown, let us assume that it is non-zero. It may be small, but it is not 0. So theta is of this value. Now, how much is Vs, source voltage? Okay, so to get Vs, okay, so we add VR and VC. Okay, so this is Vs. Now, in terms of theta, VC and VR, using trigonometric rules, can you tell, or vector rules, how much is the magnitude of Vs or Vs square?
AC square plus VR square plus
VR
2 BC
square,
cos
yes,
theta.
absolutely right. Plus 2 VR VC cos theta. Now from this, can we say that magnitude of Vs should be less than VR plus VC?
Yes.
Yes, sir.
Acha. Can we also say that magnitude of Vs squared should be greater than VR square plus VC square?
Yes.
The second one is more
Yes, sir.
obvious. Okay, so these are the two conditions we must satisfy. Now let us check among these four possible given options, which one is satisfying both these conditions. The first one, is it satisfying? So Vs is 100. Okay, Vs is, mod Vs is 100. Okay, so VR plus VC cannot be 65 plus 35 because then this first condition will be violated. Okay, let me call it 1 and 2. Okay, so the sum of the two voltages should be greater than Vs, so that is not satisfied. So condition 1 is, option 1 is not possible. Is option 2 possible? Please check and tell me.
So no option possible. All of
Yeah,
No.
this is also violating condition 1. Okay, now say option C. So here condition 1 is satisfied. Okay, 100 is less than 150, but is condition 2 satisfied? No. So this is not satisfying
No.
condition 2, and the third one is again not satisfying condition 2. So actually no option is possible in this question. Okay,
Sir, Vs should be 100 by root 2, no?
Vs should be
100 by root 2, no, sir? Like,
no, this is just
peak
the,
value is not. Sir, that is peak value, no?
no, see, this is one convention. If it is not specified explicitly whether it is peak or RMS value, then by default it is RMS value. Okay, here anything specified? Supplied from a single phase 50 hertz. Yeah, since nothing is specified, so this is RMS. Okay. And anyway, in this question it doesn't matter actually. So even if you take this as the peak value, okay, then you should also take all these values as peak values, right? You should not do partiality here and there. So if you
No, sir. That has been given as VR and VC we have to find. So
here it is written
sir,
RMS.
in that,
Yeah,
yes.
yeah. Here it is written RMS. Yeah. Okay. Yeah. But anyway, if nothing is mentioned, then by default we will take that as RMS value. Yeah. Okay. Yeah. Fine. Yeah, this question is very easy, so I will let you solve it. Okay. So we have to find this current I. This capacitor is 1 farad, inductance is 1 Henry. How much is omega?
1.
Yeah, omega is also 1. Okay, so this capacitive impedance will be how much? Minus J.
Minus J1.
0, sir.
And yeah, so together they are 0. So these two together is 0. So if so, then how much is I?
1.
Yes. So these two together is
1.
0. Okay, and then
1
0
by 2.
is in parallel with 1 is 0. So therefore I is the source voltage 1 sine t volt divided by 1 ohm. So that is just 1 sine t ampere. So RMS value will be
By 2 ohms, sir. By
No,
2
no.
But 2 no,
ohms.
sir.
sorry, no. This 1 ohm and 0 they are in parallel. Okay.
No, sir. Inside the voltage source, there is
Okay,
one
so
ohm.
open circuit it will become.
Yeah, no, let's consider this
Short
part.
circuit.
Okay, so how much is the equivalent impedance of this part? So this is 1
Yes.
parallel 0, which is 0. Okay. So that part is effectively short circuited. Fine. Any question here? Achha, so
Okay, so it will be short circuited then.
yeah. These upper two branches, they are effectively short circuit. Achha, this question we will solve later after we study resonance. Yeah, let us take some question related to power. Okay, find the average value, average power delivered to an impedance 4 minus j3 by the current 5 cos 100 pi t plus 100. Okay, so we have basically an impedance with 4 ohm equivalent resistance and minus j3 ohm capacitive impedance. Current is 5. So how much is RMS value here? 5 by
Sir, is it
2.
50 watt?
Yes. Yeah. So this is the current. Now this current is going through both the resistance and the capacitance, but the capacitor will not consume any power, average power. Okay, so the average power is only consumed by the resistance. So average power will be I square R 5 by root 2 square into 4 watt. So that is 50, correct? 25 into 250. Yeah. Fine. Achha, here is another question. So we have here a impedance, some load, the voltage and the current are given. So let this be the IT and let the voltage be like this, plus minus VT. I and V are given. How much is the average power? How do we solve it? What do we have to do first?
Phase difference.
Phase difference, yes, right.
Phase difference.
Yeah. Okay, so basically, average power is VRMS, IRMS into cosine of the phase difference between the voltage and current. Okay, so how much is VRMS? That is 170 by root 2. IRMS is 8 by root 2. But how much is theta?
60. 60 degree pi by 3.
Let me check.
Sine and cos.
Yeah, so one is in the form of a sine function, another is in cosine function. Please mute yourselves. Yeah, thank you, Tirath. So we have to first express both either in the form of a sine function or in the form of a cosine function, whichever you like. So I can write it in this way: 8 sine 377t plus pi by 6 means in degrees 30 plus 90 to convert cos to sine. Okay, this is in ampere. And how much is Vt? Okay, so you can keep this as it is, or if you like, you can correct for this minus sign. So you can do it in many different ways. So one way is this, 1 sine 377 t minus pi by 6 is 30 degree, and then to get rid of this minus sign outside, let me add 180 degree inside. Okay, so then how much is the phase difference between these two? This is 150, this is 120. So difference is 30. Okay, so cosine 30. And then you can find the value. Okay, fine. This question maybe we will take later. Yeah, let me take this one. Okay, the total power dissipated in this total circuit is 1000 watt, and we have to find the value of XL. How much is XL? Okay, and yeah, what else do we know? So here we have a voltmeter. So the total voltage across XL and R is 200 volt. What else? Here we have 10 ampere. That means this is also 10 ampere. And how much is this current here? Again 10. Acha. What? Here we have 2 ampere. Then across this resistance, how much is the power dissipated in this resistance? I square R is 4 watt. Okay, yeah. So if so, then across this resistance, how much is the power? That is 1000 minus 4 watt, which is 996 watt, and this should be equal to 10 square, 10 ampere square into R. So how much is R? 9.96 watt, ohm. Okay, so R is known. Then now how can we finish? We have to find XL. Okay.
Total power across this can be V into I.
Total power across this XL and R is same as 996 watt, because inductor will not consume any power. Okay, so we have to
The
use
current is equal to 20 by
The
R
potential difference
right,
between X.
right.
Potential difference is given.
Yes, absolutely right. So that's what we have to use. So okay, so now we can write that this potential difference 200 volt divided by the current 10 ampere, this should be equal to the magnitude of this impedance R and XL. So that will be R square plus mod XL square and square root of that. Okay, because I mean these two together is same as R square plus JXL, R plus JXL, not J, I mean J may be in, already taken care of inside XL. Okay, so yeah, so this is yeah, from this the right side is okay, so we can so left side is 20 square 400, and the right side will be 9.96 squared plus mod XL squared. From this you can get the value of XL. How much is that value? Anyone?
17.34.
So that means XL then will be equal to J into 17.34 ohm. Please check the value. Okay, yeah.
Sir, in this
So how
question,
did we get that 10 ampere?
Which 10 ampere? This one?
Yes, sir.
Yeah, because voltmeters are not supposed to pass any current through them. Okay, they supposed to have infinite impedance. So the voltmeters ideally have infinite impedance, and ammeters have zero impedance. Okay, so I will talk
So that
about
200 volt, what is that, sir?
Pardon?
200 volt, what is it?
200 volt is the reading of this voltmeter. Okay, so it means if you measure the voltage between, say, call this P and call this Q, between P and Q, the voltage is 200 volt. Okay, so this voltmeter dial reads 200 volt.
So it reads both resistive as well as reactive voltage.
Okay, I will talk about these meters maybe next day in the theory class. So here this is the RMS value of the voltage. Okay, yeah, actually it's a very good question. How do we know that? So I will have to talk about the meters. I will do it in the next class. Okay, please remind me if I forget.
Okay, sir.
Yeah. This question we will take later. Do we have time? It's already 5 o'clock, so let's stop. We will take more questions some other day. Okay, so thank you.